What do you think the state of sustainable solutions is in the market? I know that you feel that you guys lead the market, but where do you feel it is?
How can we reduce water consumption? We are very active now, for example, in the food and beverage industry, where we help industrial facilities to save water on the food manufacturing.
Welcome to the BIM Heroes Podcast. On this episode, we will discuss the state of sustainable solutions. Welcome, Alon.
Thank you very much.
Before we get started, I'd like to just do some introductions. Could you explain who you are and then what company you work for and a little bit about the history of how you got here?
Hi, Cody. Thank you for having me. My name is Alon. I'm a WINT CEO for the last 5 years. Actually, my background is actually not related to water at all, to say to say the truth. Grew up in technology world, actually mostly on telecom technologies and mobile development. 5 years ago, I was asked to come and take a look at WINT and lead it. And to tell you, frankly, my initial response was, "Leave me alone. I'm not a plumber." and and but I decided to take a look at that domain seriously, and I learned that it's a huge market with a huge demand and a very big market pain when it comes to both sustainability and water damages. Okay. And there are not too many good solutions out there like that. Tons of technologies, tons of solutions, but nothing that is really good. I like the technology, and I decided to join the company.
Tell me a little bit about WINT, what its purpose is, what it was set up to do, and a little bit of its history.
Yeah. So WINT stands for WINT Water Intelligence. Okay. The company was established, actually, as I said, not by me, established in 2012 by a very smart Israeli engineer. As you may know, Israel is a water-stressed area for many years, and there are great water-related technologies that grew up here. This engineer actually comes from, ballistics domain. And he built a very nice house here in Israel, went on vacation, came back, and the house was literally underwater. Okay, so he decided to tackle this problem and developed, as I said, a very sophisticated solution. And I'll talk about the solution in a second. What we do on a very high level, we are deploying IoT sensors around the buildings. It can be any type of building, from a residential home to commercial buildings to big facilities, construction sites, industrial lines. Okay, and these sensors are water flow meters from any shape and form. And what we do, we analyze the water flow in the pipe in real time at a very high resolution. Okay, this analysis allows us to establish baselines of normal flows and makes us very efficient in detecting abnormalities of water flow. Okay, an abnormality can be a few types of abnormality. It can be what I call a normal abnormal. If you're taking a very long shower at the gym, you don't want someone to shut off the water for you. And it can be a wasteful kind of a flow, like a faulty cooling tower, a leaky toilet, or just misconfigured irrigation. And it can be a damaging one, like a burst pipe. And we have a set of policies, of action policies that we take according to the detection. Okay, so for a leaky toilet, probably you will get a nice alert from us. If we detect a burst pipe, if you allow us, we will shut down the water for you automatically. On top of all this, we are operating a monitoring, a central monitoring that oversees all the systems worldwide, and we have over 10,000 systems already deployed. And if we detect that you have an alert in, Christmas Eve, the middle of the night on your construction site, and the system is not configured to shut off the water, for example, we will call you and we'll tell you, hey, you better send someone on site, or we can shut the water for you if you allow us. That's on a very high level, the ecosystem. And this solution makes us very efficient, and I'll talk about numbers in a second, but very efficient in saving water and very efficient in preventing water damages on real estate facilities.
Yeah, and talk a little bit about, okay, we've got the interior of the building type systems and the exterior building systems, and how that technology, the IoT sensors that you're implementing, how that would allow them to work through if there's a water damage about to occur for maintenance and so forth.
Yeah. So the system for the system itself, it's a self-learning system. Okay, it doesn't really matter for us where the system is installed, because what we do is when we install the solution, there is some kind of a basic learn period, between 2 to 4 weeks. Okay, and the system literally learns the behavior of the water consumers behind it. For example, if I'm putting a system on your floor at your office building, okay, we will learn, when the office is active, when the office is inactive. Do you have toilets? Do you have kitchens? Do you have irrigation? Do you have a cooling tower? What's their standard operation mode? What's your standard consumption per hour? Okay. And once we detect and we identify all these consumers, the system, establishes this baseline and we commission it. And once commissioned, of course, it keeps learning all the time because, winter and summer, different consumption, right? But once we commission it, we start looking for these abnormalities and taking actions upon them. We are not doing today predictive water damages detection. It's very hard to do, although it's something that we are starting now to do with all the data that we collected, and I'll talk about the data collection later.
And what about predictive, where we're talking about a situation where if an owner has multiple different jobs, but the same type of job, could you help them, assist them, and the design team on that next piece? Yeah.
Yeah, of course. So ideally, we get into the building in an ideal situation during planning, okay? Because the better you plan the solution, okay, or the deployment, you can get to a more granular data analysis, okay? And of course, the cost of deployment is much cheaper. And if you design the solution in the correct way, we are able to provide you a very good coverage across all of your facilities. We can also, for a lot of our customers, we give I want to call it a benchmark analysis, okay? So I can tell you today, if your cooling tower is faulty based on the cooling towers, in the area, or based on the weather forecast, if you want. And I talked a bit about, saving water. It's important to recognize the numbers. I was not aware of these numbers before I joined my, water intelligence. Take it as a given, okay? Every building, every commercial building wastes 25% of the water that comes in, okay? I think that's the known industry standard. We have customers Customers with the right deployment, we will always meet this average and exceed it. But I would say the average we stand today is 27%. We have campuses and universities, federal facilities wasting 49% of that comes in, okay, of the water that comes in. And one thing about water, it's not as expensive as energy per unit, but you waste a lot of it, okay? So the water waste by itself results in a huge unnecessary money spent. So there's not only, the green aspect of that, because water has also carbon footprint associated with it, but you also save a lot of money. So we find a lot of the customers that are buying the system for one reason, okay, like they want to meet their sustainability goals and save 7, 12, 20% of the water. But as part of the service, we are also protecting their building. So they're getting some insurance concessions. We are catching a lot of burst pipes and events, and we are protecting the assets. And you can see the other way around. If you're a construction site and you're buying the system to protect your construction, to protect the site, and to satisfy insurance needs, for example, and you will save so much water that only the water saving by itself will pay for the service plus.
Yeah, I think that's one of the things that's interesting about this is the reuse of water. You're seeing a lot of different methods that design teams are looking at to try to take the usage of water and, let's say, turn it into waterfall effect for roof drainage, or for data centers to try to somehow reuse that for coolant of the data center to cool the servers down. Just wanted to see, from experience that you've had, where are those biggest things that water can be reused by using the system?
So we are not doing water recycling, okay? And what we do is we are dealing with any water that runs in the pipes. It can be also recycled water, by the way. But we cut off the unnecessary waste. So, and it comes, you will be surprised. It's like my partner called it death by 1,000 paper cuts, okay? So it can be leaky toilets. I think that's the biggest water waste source today at commercial buildings. And again, I said, take it as a given, 25% water waste. Take it as a given in every commercial building, 1 or 2% of the toilets are leaking, okay, all the time on average, okay? So if you just eliminate this problem, okay, you will be saving a lot of water. Faulty cooling towers, another huge water spender. Again, it's like a huge leaky tap. It's like a huge leaky toilet. Okay, it's a valve that is misconfigured, and you literally send tons of water and money down the drain. Okay, and you don't even see it. You just see huge water bills, but a lot of our customers, they just think it's normal. Okay, and reverse osmosis systems. Unclean filters, kitchens, water fountains. All of these are huge spenders and huge damage, potential damage sources.
What do you think the state of sustainable solutions is in the market? I know that you feel that you guys lead the market, but where do you feel it is right now?
Yeah, so I think, to be frank, water is a bit lagging behind energy. Okay, I think and the focus until now, not now, but until a few years ago, was definitely started with energy, heating, cooling, lighting, you know. Um, but I see a huge tailwind when it comes to water. I see a lot of we just get tons of requests from a lot of enterprise customers to come take a look at how can we reduce water consumption. We are very active now, for example, in the food and beverage industry, where we help industrial facilities to save water on the food manufacturing. And for these companies, you know, being sustainable is one of their key principles, and water is definitely on the top two of or three items that they deal with. Um, it, as I said, water has a very this very clear carbon footprint associated with it. Okay, the calculation basically shows that 1 cubic meter of water generates around 10 kilos of carbon footprint. Okay, and the reason is, you know, usually it's water that you heat, you deliver, you desalinate, you pump, you know, there's a lot of carbon associated with these activities. And the fact that you are able to save 25% of the water, okay, basically helps you also to address the carbon footprint and, issues. And I think what I see today, beyond the fact that people are telling us, hey, we need a solution that will give us data. They tell us we need a solution that will help us save, okay, and will generate for us a lot of data insights that are related to ESG reporting, okay. So we are invested a lot now. We are investing a lot now in data generation and data analysis, also predictive data, you know, and they also integrating with existing ESG reporting platforms that are out there, because a lot of the building owners, they don't want to collect the data from this system, from that system, you know. They want everything to be visible in one dashboard, and that's what we are investing right now.
What would you say the toughest client in terms of project type? High rises, universities, data centers, hospitals.
Yeah. Great question. I'll tell you, how can I say it? The problem itself seems very easy. Okay, think about it. It's very easy to tell you, if I'm putting a system on your house, okay, at your house. It's very you either you're on vacation and then you see that, I don't know, you allow only irrigation to work or at a certain hour, okay, or you know how much water you consume in a day, and it's very easy to detect anomalies when it comes to residential homes. When it comes to commercial building, any commercial building, and that's what I'm saying, it doesn't matter if it's a university, high rise, data center, any commercial building, offices, for example. You are dealing with two problems. First, they have many more water systems than just what we call domestic water. Okay, the water that you see on your, at your sink in the kitchen. Think about all the cooling system is based on water. Hydrants, fire hydrants, sprinklers, irrigation. You have what we call hot water loops. These, especially you see them on hospitalities and high rises. These are hot water that is running constantly all the time in the building, because at high floors you want immediate access to hot water. You have cold water loops, And for each one of these systems, or each water systems, it's very hard to detect, let's call it abnormality, okay, at a very high confidence. Now, the high confidence is very important here. Why? Because if I'm a facility manager in a building and I have, let's say, 30 floors, okay, or 30 wind systems, okay, if I'm getting one false alert a day, okay, it's think about it, it's like 30 alerts a week, okay, or these are the numbers. Now, each system, if you give one or too many false alerts, eventually the facility manager on the ground will just bypass the system or turns it off, because there's a limit of how much you can send your maintenance people to check every false alert. So what I say, our claim to fame is the ability, on one hand, to be able to address or to find any leak, okay, or any abnormal flow at a very high confidence, what I call insurance grade confidence, okay, that an insurance company can say, okay, he saved the building for us, okay, and on the other hand, to do it with a very low false positives, okay. So that's the clear, if you want me to purify what is the essence of the problem, it's to walk on this fine line, on one hand to detect everything, and on the other hand not to over alert, okay, or not to overact. Now, as I said, on residential homes it's very easy. On commercial facilities, think about it, at the hospital, you have so many potential water consumers, showers, cooling systems. They have a very expensive imaging equipment that you need to protect, right? So you need to put enough systems to be able to cover it. You need to put the right algorithms for each water systems, because working on a hot water loop is very different than just monitoring domestic line. And you need to have different action policies for each one. And if you don't do that, after 2 days, I promise you, you will get a very angry call from the facility manager. Okay, and we have a lot of experience and a lot of very special algorithms for each one of these potential use cases.
Yeah, that's the thing about hospitals, is hospitals have backups of backups, because if one of those goes down, the hospital can't go down, or it would be a major problem.
And think about today I'm starting to see hospitals until today, to my opinion, just based on what I see, maybe I'm wrong, but you don't see too many water damages mitigation plans. I think there was one hospital in Atlanta, maybe last year or 2 years ago, that was shut down for very good few months. Okay, so leave aside the cost of not operating the facility, but this is a solution that we can, right now we are doing a deployment at one healthcare facility, and they are self-insured, so for them it's no brainer to install such a system.
Absolutely. Let's get into the actual solutions. So looking at a client, and we're getting ready to, let's say, in construction, we'll talk about those solutions for, let's say, a contractor and the owner, and then turning it over, commissioning, and then into facility.
Yeah. So yes, when it comes to what we call, let's call it a building life cycle. Okay, so you have construction, then the building turns into operational, right? And it goes, and you have also, some kind of a warranty period from the GC, and then, Maybe you even change owners later on, you know. So the motivation for each one of the stakeholders at each phase um, are a bit different. Okay, if you are a GC, the most important thing that you care about is to satisfy the insurance needs. Okay, and I'll talk about that in a second. And of course, to have a very predictable building, build project, right? Because every water damage will cost you months of delays, and not to talk about, reputation and money and stuff like that. When it comes to insurance, um, you know, until a few years ago, the insurance industry didn't look at this. The, the biggest problem for the insurance industry until a few years ago was actually fire. Okay, and they did quite a good job at eliminating that problem. Not completely, of course, but you have sprinklers, you have fire alarms, all this. And then what happens is today the biggest reason for water claims, for insurance claims on construction sites is actually water. Something like, I think, 40% of the claims are water related. Okay. And actually, I heard this name by one of the insurance carrier. Water is the new fire, they call it. Okay, so they're tackling this problem in a very aggressive way. And the first way for them to attack it is also, of course, to raise the deductibles. Okay, so if you are a GC today, when you buy a builder's risk insurance for your construction site, it's very common to commit for a $250,000 or $500,000 deductible for a water event, where in the past, when I'm saying in the past, 2 years ago, it was $10,000. Okay, so, and any construction manager you'll ask, they know, they are familiar with the problem. Okay, so for them to install such a system, again, it's no brainer. And now you see more and more insurance companies actually mandating the use of such a solution, not necessarily WINT to be open, but a different kind of solutions. Now, and when it comes to the owner can have a bit of a different motivation. Okay, the first motivation, of course, is to protect the asset. Okay, even in the case that they don't get insurance concessions, although in most cases they do with the right solutions. And the second one is usually to save costs and to meet ESG goals. If you're paying the water for your tenants, you want to save water. If you have, if you own the asset, a water damage that hits the building will damage the asset, and then you deal with mold and long-term effects. So the ideal solution, as I see it today, and we are doing it very successful with some of the GCs and the owners, we are engaging in the building, or we are engaging in the construction already in the design phase, okay? And we bring all the stakeholders to the table. We'll bring the GC, we will bring the insurance company and the risk officer on behalf of the GC, and we will bring the owner representative, okay? Now, what we do, we sit together and we design the solution in a way that will be very beneficial for the owner, will bring a lot of value to the owner, okay? And that the GC can already use it during the construction phase, okay? So the GC installs it. Of course, it's part of the building specifications. You pay a fraction of what you will pay if you need to retrofit it, okay? And then you have a much better coverage of the building because you put more systems and you put the right systems and the right water systems. And then basically the transition is very smooth. Okay, you put the systems. Every time you put a new section of pipes, when you go to fit out, you will put the right systems. You finish the buildings, you commission you TSO the building, and the systems are being transferred to the building owner exactly as you transfer the elevators and all the other mechanical systems in the building.
Is there a particular solution that you see the most used? Is it you know something where the elevator, there's a leak and the pit fills up, pipes are bursting, and then that causes mass issues, even in the testing aspect of it, of different pipes. What's some of the things that you've seen that
Yeah,
it's picked up on the most?
so again, you will be surprised by how it happens. The minute you put systems, you put water in the systems, it can be a wrong, a faulty welding. It can be one of the after you commission the water pipes, you can have another contractor that drilled into the pipe by coincidence. Happens a lot. It can be, a faulty sprinkler head. Okay, and tons of cases, tons of reasons. I'm actually surprised every time by the reasons. Sometimes you even see malicious, employees' activities. Construction employees that want to, are not happy with their employer, right? So we are able to detect all of them, and the nice thing about that is not that we only detect them, we are preventing them very fast, I want to say. Okay, so because we are deploying our shut-off valves, 90% of the cases, I would say, we are deploying auto shut-off, okay, policies. So the systems will detect the leak, okay, and will take action. So, if you come to the construction site in the morning, you might see some water on the ground, but you won't have a demolished building. Okay, and literally you see damages of. I I talked with a GC that suffered the damage of many tens of millions of dollars. Okay, so you won't see that with such a system. Now, the old technology that used to deal with it was simple water packs, that you put at the bottom of the elevator shaft. Okay, and when it senses water, you will hear a beep or you even shut off the water, right? But usually when it senses water, it's too late, okay? Because first, it's very hard to cover the whole building. And secondly, already you felt water, right? It means water flows somewhere. What we are doing, because we are deploying it at the building feeding points, we are detecting the leak at the source, and we are able to shut off the water at the source. Okay, so and you'll be surprised how many events you see on a daily basis. It's unbelievable. It's just an anecdote. When I joined the company, and it's usually Sunday, Mondays after the weekend. And in the weekend, the water pressure in the pipes goes up because you have less users. And and I was Mondays are very busy for us, because people are coming to the office and they don't have water, or they see some damages. And I was sure that maybe it's a mistake by our system. Me personally, I was not a big believer until I saw the systems in action. Okay, and it just takes time to understand that it's every building has it. The majority of the construction sites will suffer from it. Okay, and the amount of water spent is, as I said, it's huge. It's 27%. As I said, it's the average. But we have customers that the water bills, we cut them by 2/3, by 80% after 3 weeks of using the system.
And then talk a little bit about it's a fitting that gets put onto the pipes that are doing the sensing, or is it sensors inside the pipes? Explain
No,
that.
it's water flow meters.
Okay.
Um, Now it's not a standard water flow meter. It's a water flow meter that has certain reading capabilities and report a data transferring capabilities. Yeah, you cut the pipe, okay, or you are just reading existing water meters, right? So if you're doing, as I said, if you are specifying the solution in the right way or at the right time, I can just say, okay, just instead of these water meters, use these ones, okay, and then we just read them, okay. And because and the system usually comes with a shuttle valves, okay, not necessarily. We have customers that have many sensors and one shuttle valve for the whole building. You can do whatever you want. Um, and and what we do is the water flow, the water flow sensor, the meter, as I said, reads the flow at a very high and resolution, and streamlining it, streaming it outside in real time to the computer that runs the calculation. Okay, we run the calculation usually locally. We don't we communicate everything to the cloud, but the system is able to take decisions by itself because, as I said, it's an insurance grade system, right? So you cannot depend on network availability, and you need to be active very fast. Okay, and the system, what we do is think about it almost like an electric signal. Okay, and we read the water flow rate over time. Okay, and we are analyzing these signals. It's almost like reading a heart pulse rate, and I know when the building has an issue, okay, or when it's a normal flow, and we compare it. So it's almost like an imaging processing. We compare it versus normal all the time. We look for these abnormalities. Uh, and that's it. It sounds simple, but when you have a lot of events on top of each other, this analysis is not as easy as it sounds.
So working with the design into the contractor standpoint when they're doing testing on the system, you're analyzing those tests as it's going through that process into commissioning and then into turning the building over to the facility.
Yeah, the minute there is water in the pipes, we're good to go.
Do you see when you come back and let's say there's data that's being done during the testing where there might be some weak points in the system, do you see that is fixed and they are no longer a problem? Or is it something where, if there's another leak down the road, the first thing we look at is the couple areas that you saw that were problem areas back when they were doing that?
So no, for us it doesn't really matter. We will detect any event, okay, and even if you have two events on the same pipe, okay, we will detect both of them. Okay, so it doesn't really matter. The potential damage of these things is so high that the contractors or the building owners, trust me, if once they have the system, they take these alerts very, very, very seriously. Okay, so they go address them, they fix them, and once you fix them, again, it's you're not getting too many alerts. Let's say this way.
So when a facility manager is, contracted by the owner to then run their facilities, what would that dashboard look like for them to help them, as you talked about earlier? They're not running to every single alert that comes on, but let's say here's where we've got a big issue here.
Yeah, so they will get the type of the alert, okay, whether it's a low flow or high flow or moderate. They will get a severity. They can get also a call from us, and we can tell them, "You better run now." Okay, and they get the location. Okay, and they get all the history. Okay, so you can, and by the way, you get it, of course, you get it on your dashboard, but you get it on your mobile app. So from your mobile app, you can actually literally shut off the valve, okay, if it's not shutting off automatically. And you can get it on your building management system. So, and then, doesn't have to be facility manager, it can be even security guy in the middle of the night.
There's a lot of those alerts, mainly water leaks, or is it all different types of sensing that it's trying to look at?
Hey, I'm not sure I understand the question.
Yeah, so if it's a water leak at a valve versus a water leak at a fitting, or it's too much pressure in the pipe and it's going to cause it to burst, I would assume it incorporates any of those things.
Yes, all of them. Yeah, there's a lot of experience in. We built let's call it as a dictionary, okay, of normal flows, okay. So we have tons of algorithms that can address tons of crazy use cases, okay, because a burst water fountain in the kitchen, okay, will behave very differently than a burst toilet, okay, or a burst pipe, main pipe, okay. So to detect a leak here or to detect a leak there, different amount of water, different amount of, different behavior, um, and not necessarily lesser damage. Okay, you can have a small water bar that will leak 100 liters during the night and will demolish an elevator system for $300,000. Okay, so you can see that all the time.
Does it integrate with the building system management?
Yeah.
And talk a little bit about that.
Yeah, so a lot of the customers, as I said, not everybody wants to see to have 20 dashboard, one for the power, one for the elevators, one for the heating, and one for water. Okay, so they're trying to concentrate everything into one system. Usually it's the BMS, the building management system, but not always. And they're asking us to get all the alerts there. And the more sophisticated building owners or facility managers, what they will ask us to do and what they ask us to do, they want us also not only to report, but also immediately to open a ticket for the facility manager. Okay, and then they're able automatically to be on top of every alert. So we need to integrate not only to the BMS, but also to the facility management ticketing system. Okay, so yeah, and now another type of integration is, as I said, it's the ESG carbon footprint monitoring that people are starting to implement.
Yeah, and are they able to manage that system in the system that's finding the leaks? Can they change the controls, or does the facility management group need to go to the system still and make those adjustments?
Depend on the level of integration. Okay, the system doesn't need too much, let's call it manual intervention. Okay, so really and truly, you don't need to touch it and adjust it too much. And if it's well planned in the design, and so most of the integration, what we provide is the data and the alerts, and the ability to shut off the water. But if you need to change settings and policies and stuff like that, the best way to do it, usually we will send you to our system. I don't think we have any integration that allows this as well, although it's very easy. Everything is open API. We can do that. I just don't have an experience with it.
I guess that's a next lead in. Do you use like a building information model to bring into it, or is it mainly the sensors themselves?
So no, these are the sensors. we do provide the designers with the ability, to incorporate our systems in their design plans. Okay, we have a nice library, we equip them with all the files they need, but at the end of the day, it's the sensor itself.
And then from that documentation, a lot of the buildings that we're working on now have LEED accreditation and different sustainability programs outside of LEED. How would the system be able to help not only the contractor work through some of those things during construction, but then also on the back end to make sure that they fulfill those requirements?
Yeah, so so the answer is definitely we provide a LEED accreditation, and it's not only LEED, okay? Because in the UK, for example, you see more, BREEAM and the neighbors now, and so we are providing points, okay, when it comes to water performance score, it's called. Yeah, we are providing points. We help a lot of our customers are using the system also to accumulate lead points. Okay, and this by itself also, additional motivation, usually by the owner, to deploy the system. Yeah.
Yeah, and that's doing construction and also after construction, mainly
Yeah.
to make sure that they're fulfilling the requirements that we're trying to set forth. But just a project that I'm working on is a LEED Platinum project, and they're doing everything that you can imagine within that program, and even further with some of the reclaimed of that water to try to reuse it. So it's definitely one of those systems, like trying to figure out how to get through construction and the insurance piece of that, but also to keep that that building running in a sustainable way.
Exactly, and I said, not it still depends. You see some differences between the geographies. I know you're based in the States, but we are very active. For example, in the UK, Europe, Gulf area. Now we're starting with another region, and so you get points. A bit of a different system, but the same idea. In Australia and the UK, you see, as I said, the neighbors are BREEAM more important to them, and I think actually there we're even more efficient than LEED itself.
On a separate note, in a different direction, from the IoT sensors, do you see a lot of need? During construction, we always have, or looking at leaks. There's different ways to do it with sensors and things like that. But do you also see a need to incorporate something like, a camera into it? And how would that be integrated into a system?
So we don't, our solution, especially what we're deploying now, which is our next generation solution, what we call, is let's call it a processing power. It has processing power to do much more than just water, okay, or just water leak detection. So we are now, adding more sensors that will give you, the building owner, a more holistic picture of what's going on in your building when it comes to the IoT sensors, with regards to ESG or risk mitigation. Camera is not one of them, although it's a good idea. Okay, and I'll say one thing about cameras in a second, but it's sensors like energy, like water quality, like humidity, temperature, stuff like that. I can tell you that we are working very closely with the construction camera solutions. Okay, mostly to satisfy insurance needs. Okay, and for them, they are providing now a very high level water risk, water damage mitigation, and we are able to provide, security needs or other, other visual needs. And yeah, so we have a few partners we're working very close. It's not our, direct expertise, let's say.
Yeah, because I think that that's going to be the next piece of this is that water intelligence type, where you take the sensors and the information you're collecting, you have a means to have analytics. You can then do KPIs off of that, and then maybe machine learning with AI. Just wanted to see on those different topics where that
Yeah.
could go.
So that's what we do today. We do it only on water, but definitely there's a room to do a cross sensors kind of analysis. Okay. As I said, for an example, uh, the relations between water pressure in the pipes and burst pipes, or predictive burst, predicting burst pipes, right? Temperature and cooling and heating. And that the sky's the limit of what I can think of, what we can do here.
Do you also see a potential of breaking away somewhat from just pipes, but let's say building envelopes? I know one of the things that biggest challenge we have in the US, other than leaks that occur in the building, is just leaks in general
Yeah.
with the envelope.
Yeah, one of the customers I met yesterday called it, we have two types of leaks, human water and God's water. Okay, so God water. Um, yeah, so definitely that's here. The way to deal with it is actually the water packs, the water sensors that I talked before. If a customer wants to cover themselves from that, we definitely do it. We integrate it to our systems. It's not. No, it's definitely a need. It's not only that; it also goes for wastewater. Sometimes you have wastewater that goes up. So that's also a need that we can address.
The last question I have, where do you see the future of sustainable solutions going? Where's WINT's mission from here?
Yeah, I would say data. It's it, First, we are collecting a lot of data that is very relevant for the insurance industry, very relevant for the sustainability officers in these buildings. But it's not only us, right? So uh, uh, not only the regulations, okay, what they require, that also building owners. They need to report this to their shareholders, and using this data, you can also learn a lot, okay, and you can also take very different actions. So, to my opinion, and we are investing a lot in it right now, is the ability to not only to act but also to collect the data and to present it and to analyze it in a way that you as a building owner, you will understand, for example, how much carbon footprint each employee brings, for example, stuff like that. And, or how much, how much energy you spend on employees, on floors, on different type of buildings. Is this building more efficient than that one? Then you need to satisfy some regulations in this state or that state. And all of this is becoming very important. And this is what we are investing in, not only in collecting and putting the machine learning on that, but also to integrate it with data aggregation platforms.
Alon, I want to thank you for joining me today on the BIM Heroes Podcast.
Thank you very much for having me.